And so we've looked at proportionalities, the way two variables might be related as a result of some sort of experiment. Well, we're going to go from proportionality to proportionality constants. This allows us to go from proportionalities to equations. Now we see lots of proportionality constants out there. So Newton's universal law of gravitation, we know that the force between two bodies is proportional to the mass of the first body, the mass of the second body, and inversely proportional to the distance between them. We can turn this into an equation by adding in our proportionality constant g, which is Newton's gravitational constant. We see these pop up again and again because Coulomb's law looks almost exactly the same, and we can turn the proportionality statement into an equation if we can find out what k is, which of course is Coulomb's constant. So straightforwardly enough, if we found the relationship between two parameters and we managed to turn it into a straight curve, so in this case we know that force is inversely proportional to the radius squared, I can turn it into an equation. I can say, well, force is equal to something times 1 over the radius squared. And that something, of course, is actually going to be the slope, and that becomes my proportionality constant k. Now, we have a couple ways we can do this. If we can straighten the relationship, we can take the slope directly, or even better, once I have my proportionality figured out, if I have two of these values, a force and a radius, I can actually just turn it into a matter of isolating the proportionality constant. And that's how I can establish an equation from a proportionality.